Hi everyone, today we are looking at lesson 2, which is going to focus on perpendicular lines. We are still focusing on math practice 7. We're going to continue using our prior knowledge to help solve new problems. And our lesson objective is I will be able to identify perpendicular lines through graphing and my knowledge of linear equations. I would like for you all to start with your warm-up. It says, find the slope between each ordered pair. What do you notice about the two slopes? Well, as a reminder, your slope equation is y2 minus y1 over x2 minus x1. Find the slopes for questions 1 and 2. And once you have found those slopes, what do you notice about them? Pause the video and answer the question. Okay, I have already gone ahead and found the slopes. For the first one, I got -2, and for the second one, I got 1/2. So there's a couple of things I'm noticing. First of all, I notice that this one is negative and that this one is positive. Okay, I notice that this one is an integer. Remember, integer means not a fraction, and this one is a fraction. I also notice that they are both using the number 2 in some way. So the question is, how is this going to help us with perpendicular lines? Well, we're going to find that out today. So a perpendicular lines are lines in the same coordinate plane that intersect at a 90-degree angle. In this example, the purple and the blue line are perpendicular. So they are intersecting right here at a 90-degree angle. Please make sure you write this down with the first 2 bullet points. Okay. We're going to try to see if we can determine if the lines are perpendicular, and if so, how do we know? Well, in question number 3, I'm noticing that it is in slope-intercept form, and our slope is 3/4, and our b value is -2. I'm going to graph at -2, and I can go up 3 and right 4. I can also go down 3 and left 4 to add a third point. With this, I can connect these with a line. For my second equation, I have a slope still. It's -4/3, but I have a point now. I'm going to take the opposite of what's next to my x and y, which would be -1, -5. So -1, -5 is all the way down here, and my slope is -4/3. I can't go down 4 and right 3, so I'm going to go up 4 and left 3. Up 1, 2, 3, 4, left 1, 2, 3. And I can only fit 2 points on this graph. Now, looking at this, right, it looks like we have a 90-degree angle right here. Okay, so for now, I'm going to say that these are perpendicular. Okay, now if I look at number 4, I have a slope which is 1/5, and I also have my intercept which is 1. So we're going to plot a point at 1, and I'm going to go up 1 and right 5. I could also go down 1 and left 5 to add 1 more point, and I can connect these with a straight line. And it's super important that you are using a straight edge, like a popsicle stick, to graph. That way we have straight lines, because it's really important to see what angle these lines are at. Now, for this, I have to write and solve 2 equations. My first equation is going to be 5x is equal to 5. And when I divide by 5, I get that x is equal to 1. So I'm going to put a point at 1. For my second equation, I'm going to say that y is equal to 5. And again, I'm going to put a point on 5 here. And if I connect these, I get this line. And again, this looks like a 90-degree angle. So I'm going to say that these are perpendicular. And you know what? I already know for a fact they are perpendicular. And it's because of their slopes. Here, my slope is 3/4. Here, my slope is -4/3. There is a pattern going on here. Here, my slope is 1/5. I can find my slope of my standard form. Notice I'm going down 5 and right 1. So the slope for this one is -5/1, okay? There is going to be a correlation between our slopes and how we can determine if they're perpendicular. So we have this new vocab word. Maybe we've talked about reciprocals before, but I don't think we've ever talked about an opposite reciprocal. Opposite reciprocals are when two numbers' product equals -1. Product is just a fancy word for multiplication. So an example of that would be, okay, well, what can multiply to -1? Well, okay, 1 times -1 is -1. So those are opposite reciprocals. Okay, I want to go back actually to these questions, right? We had -2 and 1/2. I said that was going to be important. So -2 times 1/2. Well, I can actually put a 1 under my -2, and I'm going to multiply across. -2 times 1 is -2. 1 times 2 is 2. And I can divide these and I get -1. So our slopes from the first two questions we did are opposite reciprocals. Now down here it says find the opposite reciprocals of the values. There's a trick here. Let's look back at this example, okay? I had -2/1 and then +1/2. Opposite reciprocals. Opposite tells us we're going to switch signs. Reciprocal tells us we're going to flip our number. Okay, so this is switch signs, and we're going to flip our number. So if I'm looking at the number 5, I'm going to switch the sign. So if this is +5, I'm going to have a negative number. And because it's a +5, I'm going to find the reciprocal of 5, which is when I flip it. This is 5/1. The opposite of that is 1/5. That is your opposite reciprocal of +5. Now, if I were to do -2, I'm going to look at a positive number. And again, this is -2/1. So when I flip it, I get 1/2. 1/4 is positive, so I'm going to have a negative number. The flipped of 1/4 is 4/1. And then lastly, for my last one, it is negative, so I'm going to have a positive. And if I flip 4 and 5, I get 5/4. And these all are going to magically multiply to -1. And those are my opposite reciprocals. So perpendicular lines always have slopes that are opposite reciprocals. Now, on the right, I have a vertical and a horizontal line. I want to talk about those. These are a special case. So for my horizontal line, the slope is equal to 0, okay? For my vertical line, the slope is undefined. Now, we can't multiply 0 and undefined, but I am going to let you know that because we have a horizontal and a vertical line, the answer to this question, what are the slopes? Are they perpendicular? Well, we found the slopes. Are these perpendicular? Yes. Okay, so this is just a special case, or horizontal and a perpendicular, or sorry, a horizontal and a vertical line are always perpendicular. Even though we can't multiply the slopes to see if they multiply to -1. Okay, are these equations perpendicular? I'm going to do the first one with you guys. Let's find the slopes. So I notice that this one, I'm going up 1 and right 2. So our first slope is 1/2. I can then also find the other slope, which I'm going up 1, 2, 3, 4, 5, and left 2. My other slope is 5 over -2. Well, I can do the test to see if they multiply to -1. 1/2 times 5 over -2. We're going to multiply across. 1 times 5 is 5. 2 times -2 is -4. This does not equal -1, so these are not perpendicular. And it's because the slopes are not opposite reciprocals. Okay? For the next one, though, let's see what happens here. I see that I can go down 1, 2, 3, 4, and I can go right 1. So I have a slope of -4 over 1. I'm also seeing that we're going up 2 and right 1, 2, 3, 4, 5, 6, 7, 8. So my other slope is 8 over 2. Oh, I'm sorry, I flipped that. Is 2 over 8, which reduces to 1/4. If I multiply these out, 1 over 4 times -4 over 1, and I multiply across, I get 1 times -4 is -4, 4 times 1 is 4, and this does equal -1 if I reduce. So these are perpendicular. And it's because they have opposite reciprocals. There we go. Now we can do this exact math without needing a graph. We've done this before with parallel lines. So let's try number 7. What is the slope? Hopefully you said -1. What's the slope in the other one? Hopefully you said 1. Does -1 times 1 equal -1? Yes, it does. So these are perpendicular. Let's look at number 8. The slope for the first one is -1/3. Now I have to solve for y in the second one, just like we did in parallel lines. So I can subtract 3x on both sides, cross out my 3x, and I'm left with y is equal to -3x minus 12. Well, looking at this equation, my slope is -3. If I do 1/3 times -3 over 1, because there is a 1 underneath this. Oh, it's -1/3. I get -1 times -3 is +3. 3 times 1 is 3. And this equals a +1. So these are not perpendicular. Okay. I would like for you to try 9 and 10. Pause the video and see what you get for an answer. Okay, I notice here that my slope is equal to 3/7, and I need to solve here. I am going to subtract 7x on both sides, and I get negative 3y is equal to negative 7x plus 6. I have to get rid of the number in front of y, so we are going to divide by negative 3 by all three numbers. I am left with y is equal to 2 negatives become positive, and it's going to stay a fraction, which is 7/3 x. 6 divided by negative 3 is negative 2. And the slope here is 7/3. If I do 3/7 times 7/3, I get 21/21, which is positive 1. So these are not perpendicular. I can find my slope for the second one, which is negative 5/6. But if you notice, this one is in standard form. So I have to rewrite this, and I need to put it in, I have to solve for y. For this one, I'm going to subtract 6x on both sides, and I'm left with negative 5y is equal to negative 6x minus 15. I can divide every number by negative 5, and I'm left with y is equal to 2 negatives become positive, and it's going to stay a fraction. Negative 15 times negative 5 is positive 3. Notice that the slope here is 6/5. I can do negative 5/6 times 6/5, and I get negative 30/30, which gives me negative 1. So these are perpendicular. And that is our answer. Okay, the last couple questions 11 through 14, are similar to the last 4 questions we did with parallel lines. We're given 2 points that are on lines, and we have to solve for their slopes. So I'm going to start with line 1, and I'm going to find the slope. So remember, we are using this equation, y2 minus y1 over x2 minus x1. So I can do negative 7 minus 5 over 3 minus 0. This gives me negative 12/3, which gives me negative 4 as my slope. As for the second equation, line 2, I'm going to do 2 minus 5 over 3 minus 15. This gives me negative 3 over negative 12. The 2 negatives become positives, and I can divide both of these by 3. And this gives me positive 1/4. If I were to multiply negative 4 over 1 times 1/4, I get negative 4/4, which is negative 1. Because we got negative 1, they are perpendicular. I'm going to do one more with you guys. I'm going to start out with line 1. So line 1, we are going to do negative 13 minus 13 over negative 8 plus 7. This gives me negative 26 over negative 1, which is just positive 26. I'm also going to do line 2, which is negative 6 minus 20 over 10 plus 13. This gives me negative 26 over 23. Now, I could do this out. I could do 26 over 1 times negative 26 over 23. But what I can guarantee you is that this does not equal negative 1. So these are not perpendicular. I would like for you to pause the video and try the next question. Once you have unpaused the video, please check your answers. The answer for number 13 is not perpendicular, and the answer to 14 is perpendicular. If you have finished these questions, the next thing that I would like for you to move on to do is to work on your homework on IXL. It is the skill PRP, and you need to get a SMART score of 80 or higher. If you have finished that and you are good to go, you do not have anything else you need to work on for my class, and you can use the rest of the time as a study hall. I will hopefully see you all tomorrow. Bye, everyone.